Yes, ma'am. Start the class, ma'am.
Yes, sir. Good afternoon, students. In the previous class, we have seen how to find the angle between the two lines. What is the formula we have seen? How to find the angle between the two lines? The angle between the two lines is found by cos theta is equal to a1 a2 plus b1 b2 by under root of a1 square plus b1 square into a2 square plus b2 square. In the similar way, we have also seen if the two non-vertical lines are given and the slopes are mentioned, that is m1 and m2 are mentioned, then how to find the angle between that two lines, that is tan theta is equal to m1 minus mod of m1 minus m2 by under root of 1 plus m1 m2. We have seen and we have also seen the necessity and the sufficient conditions for if the two lines are parallel. If the two lines are parallel, then what is the necessary and sufficient condition? That is a1 b2 is equals to b2 b1 a2. If the lines are parallel. What about if the lines are perpendicular? If the lines are perpendicular, then we'll get a1 a2 plus b1 b2 is equals to 0. Then a1 a2 plus b1 b2 is equals to 0. These are the things we have seen in our earlier class. Today we are going to see more. That is length of the perpendicular from a point. How to find the length? How to find the length of the perpendicular? Length of the perpendicular from a point to a line, from a point to a line. So today we are going to see how to find the length of the perpendicular from a point to a line. How to find, that is theorem we have, the length of the perpendicular from the point AP x0 y0 to the straight line ax plus by plus c is equal to 0 is how much? They have given a mod of ax0 plus by0 plus c by under root of a square plus b square, under root of a square plus b square. So what they have given? They have given us a straight line. They have given us a straight line, and what they are asking us, that is, this is x, this is y dash and x dash. They have given us a straight line, that is AB is a straight line. The equation, let the equation of AB, let the equation of AB is how much? AX plus BY plus C is equals to 0. This is the equation of this straight line. This is the equation of the straight line, and there is a point P. There is a point P. If this coordinate axis, if these coordinate axes are shifted to this origin, that is P of x0 comma y0, this origin is shifted to here, that is capital X, capital Y, x dash and y dash. If comma y0 be the origin of the translated axis, then what about the coordinates? Then the coordinates also change. Then the coordinates also change. And how the coordinates will be? Small x is equals to capital X. Here we are representing it with the capital X and a x0, comma y is equal to capital Y plus y0, capital Y plus y0, where this is the origin. X0 and y0 are the origin with respect to the new axis. Origin with respect to the new axis. Therefore, what can we say with respect to the new origin? Then how this equation will be? Therefore, the equation of AB the equation of AB with reference to new axis, with reference to the P, with reference to the P is how much? That is A into capital X plus X naught plus B into how much? Plus B into Y plus Y naught plus C is equal to 0, plus C is equal to 0. That is AX plus B capital Y plus, if I write AX naught plus BY naught plus C is equal to 0, plus B is equal to 0. Here this is nothing but the constant C. Therefore, we know the perpendicular distance from the origin is given by perpendicular distance from origin. Perpendicular distance from the origin is given by, what is the formula? Is given by C by under root of A square plus B square, under root of A square plus B square. But here what is the C we have? Therefore, here PM is the perpendicular. Therefore, PM is equal to how much we have? That is AX naught plus BY naught plus C by under root of A square plus B square, mod of AX naught plus BY naught plus C by under root of A square plus B square. That is the perpendicular distance from a point to a line. This is how we will find the perpendicular distance, length of the perpendicular from the point to a line. So, let us see how, once again, this is the line they have given. The line we will represent with AX plus BY plus C is equal to 0. AX plus BY plus C is equal to 0. If this point, if this origin is shifted, is shifted to a new origin, that is P of X naught, Y naught, then what about the coordinates? The coordinates also get changed, and the coordinates are changed from X comma Y to, the coordinates will change from X comma Y to capital X comma capital Y. The coordinates will change from small xy to capital X comma capital Y. Therefore, we'll get X is equal to X naught, X is equal to capital X plus X naught, and Y is equal to capital Y plus Y naught. Therefore, the equation of this AB with respect to this axis, that is the new axis, is A into X plus X naught plus B into Y plus Y naught plus C is equal to 0. If I multiply this, that is A into X plus B into Y plus A into X naught plus B into Y naught plus C. We know that perpendicular distance from the origin is given by mod C by under root of A square plus B square. Therefore, perpendicular distance is equal to mod of A X naught plus B Y naught plus C by under root of A square plus B square. A square plus B square. This is how we will find the length of the perpendicular from a point to a line. Let us see a sum. Let us see a problem regarding this concept. That is, they have mentioned in example, that is in the page number 60, in the example, find the perpendicular distance from a point to a straight line. From a point to a straight line. Find the distance from a point to the straight line. What is the straight line they have mentioned here? What is the straight line? That is, they have given as phi x, that is example, we have phi x minus 12y is equal to 2, pi x minus 12y, and also they have mentioned the point. What is the point they have mentioned here? That is minus 3 comma 4, minus 3 comma 4. Now, to find the perpendicular distance, as we know, perpendicular distance is equal to mod of Ax naught plus By naught plus C by under root of A square plus B square. So from this, what is A? If this equation can be written as phi x minus 12y, get this 2 to the other side. So minus 2 is equal to 0. This implies A is equal to 5, B is equal to minus 12, and C is equal to minus 2. Just substitute the values. That is mod of, what is A? 5. What is x naught here? Minus 3 plus b is how much? Minus 12. Y naught is 4. minus 2 by under root of, what is A? A is 5 square plus minus 12 whole square. 5 square plus minus 12 whole square. So how much we'll get? That is minus 15 minus 12, 48 minus 2 by under root of 25 plus 144. 25 plus 144. So how much we are going to get this? That is equal to, so here how much we'll get? Minus 48 minus 2 is 50. 50 minus 50 minus 15 is minus 65. As it is a mod, so we have to take the plus value. That is by, what is this? Root of 169 is 13. Therefore, I'm writing 13. Therefore, how much I'll get? I will get it as 5. I'll get it as 5. So this is how we will find, if they have given the point and the line, this is how we will find the perpendicular distance. This is how we will find the perpendicular distance. So next one, similar kind of problems you have in your exercise also. So you all have to do that problems. So next concept, what you have, how to find the distance between the two parallel lines. Distance between two parallel lines. Distance between two parallel lines. How to find the distance between these two parallel lines. So here, what they have given, the distance between the parallel straight lines ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0 if mod of c1 minus c2 by under root of a square plus b square. Mod of c1 minus c2 by under root of a square plus b square. So what they have given the line L1 as ax plus by plus c1 is equal to 0 and line L2 as ax plus by plus c2 is equal to 0. We know that parallel lines differ only by the constants. Parallel lines differ only by the constants. So we have, so what they, so this is the origin, this is x-axis and this is the y-axis. We have taken two parallel lines. We have taken two parallel lines, that is line L2 and L1. And there is a point on the line L1, x0 and y0. And this is the distance between the two parallel lines. M is the foot of the perpendicular from P to the line L. So from this, these two are the lines, these two are the parallel lines and P is the point on the line. P is the point on the line. So let P of x0, y0 be the point on the line L1. On the line L1. So as this is the point on the line L1, then this equation turns to be how much? That is ax0 plus by0 plus c1 is equal to 0, or this can also be written as ax0 plus by0 is equal to minus c1. Put it as equation 1. Take it as equation 1. Now, we know that L1 is parallel to L2. L1 is parallel to L2 and the distance between these two lines, distance between L1 and L2 is PM. What is the PM? PM is a perpendicular. PM is the perpendicular distance from P to L2. From P to L2. Perpendicular distance on L2. Therefore, we can write PM is equal to what? We know the perpendicular distance is given by A into perpendicular distance is given by how much? Perpendicular distance is given by mod of Ax naught from on the line L2. So in the line L2 we need to substitute this point Ax naught plus By naught plus C2 by under root of A square plus B square. But from equation 1, what we know that Ax naught plus, from the equation 1, we know that Ax naught plus By naught is equal to minus C1. Therefore, we'll get mod of minus C1 plus C2 by under root of A square plus B square, under root of A square plus B square. This can also be written as we are taking the mod. So C1 minus C2 by under root of A square plus B square. A square plus. Therefore, the distance between two parallel lines, is given by mod C1 minus C2 by under root of A square plus B square, under root of A square plus B square. What we have taken, they have mentioned that there are two lines parallel to each other. There are two lines parallel to each other, and the lines are represented as Ax plus By plus C1 is equal to 0, and the line 2 is represented as Ax plus By plus C2 is equal to 0. So we are considering a point P on the line L. Therefore, we'll get it as Ax naught plus By naught plus C1 is equal to 0. So from this, what we are doing? We are just shifting C1 to the other side. So we are getting Ax naught plus By naught is equal to minus C1. Now we know that these two lines are parallel. The distance between these two lines is given by PM. PM is also the perpendicular distance. This is the perpendicular distance onto the line L. Onto the line L2, we know the formula for to find the perpendicular distance. Perpendicular distance is found by Ax naught plus By naught plus to the line L2 plus C2 by under root of A square plus B square. From equation 1, we know that Ax naught plus By naught is equal to minus C1. So we are substituting here minus C1 plus C2 by under root of A square plus B square. This can also be written as mod of, as we have a mod, so we can write C1 minus C2 by under root of A square plus B square. So this is how we will find the distance between the two parallel lines. Distance between the two parallel lines. Distance between the two parallel lines. So let us look at some. Find the distance between the parallel lines. They have given that 3x plus 4y minus 3 is equal to 0 and 6x plus 8y minus 1 is equal to 0. Put it as equation 1 and this as equation 2. So we know that parallel lines are differ by only constant. These are same to the parallel lines. So if I multiply equation 1 with 2, I'll get the same this thing. That is 6x plus 8y minus 6 is equal to 0, is equal to 0, is equal to 0. So now we are considering, I'm putting this as 1A equation. Therefore, now we can find the distance between these two parallel lines. Here Ax plus 8y, here also we have 6x plus 8y, here also I have 6x plus 8y, and they are differ by constant. So distance between the parallel lines is given by distance between parallel lines. Distance between the parallel lines is given by mod of C1 minus C2 by under root of A square plus B square. So here what we have, C1 is equal to minus 6 minus 1, that is minus 1 by under root of, how much? Under root of A square. A square is 6 square plus 8 square. 6 square plus 8 square. So how much we'll get here? We'll get minus 6 plus 1 by under root of 36 plus 64. So 36 plus 64 is nothing but 100. So root of 100 is nothing but 10. So we'll get mod, we have a minus, we'll get minus 5. Mod of minus 5 will be plus 5. So 5 by 10. Hence, we can write 1 by 2. So, this is the distance between 1 by 2 is the distance between the two parallel given two parallel lines. So next we have, this is an important one, a theorem, that is, if q h comma k is the foot of the perpendicular from the point p x1 y1 on the straight line ax plus by plus c is equal to 0, then h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by is to a square plus b square is to a square plus b square. They have given us a line. They have given us a line L, and what they are saying, there is a point. Q is the foot of the perpendicular. Q h comma k is the foot of the perpendicular from a point p x1 comma y1. From a point p x1 comma y1 on this line. This line is ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. Therefore, PQ is perpendicular to this given line. So, equation of PQ, which is perpendicular to the given line, ax plus by plus c is equal to 0, is given by, already we have discussed this, is given by what? Bx minus ay is equal to 0. Bx minus ay is equal to 0. This is the equation of PQ, Bx minus ay. We have, on this PQ, we have a point P, as P x1 comma y1 lies on the line, PQ. What does this imply? This implies that Bx1 minus ay1 is equal to 0. Also, what about Q? Q is also lying on this line PQ. Also, Q h comma k lies on the line PQ. Therefore, what will get? B into h minus a into k is equal to 0. So, we are equating these two lines. That is, BH minus AK is equal to BX1 minus AY1. BX1 minus AY1. BX1 minus AY1. Okay. So, getting this B terms, BH minus BX1 to the one side and taking this term to the other side, that is AK minus AY1. AK minus AY1. So, if I take B common, what I'll get? I'll get H minus X1. If I take A common, I'll get K minus Y1. K minus Y1. Now, H minus X, if I take this A over here and the B to the other side, then H minus X by A is equal to K minus Y1 by B. I'll get. We will, to find the value of H, we will equate this to some lambda. We will equate to some constant, that is a lambda. So, H minus X1 by A is equal to lambda and K minus Y1 B is equal to lambda. So, what will get? H is equal to A into lambda. H minus X1 is equal to A into lambda and H is equal to A lambda plus X1. In the similar way, if I take this one, then K is equal to K minus Y1 is equal to B lambda and K is equal to B lambda plus Y1. Therefore, we have found this point H comma K. But where this point H comma K is lying, H comma K also lies on the line L1. So, Q H comma K lies on the line L is equal to ax plus by plus c is equal to 0. So we are substituting that a into a lambda plus x1 plus b into b lambda plus y1 plus c is equal to 0 plus c is equal to 0. Then what can we get? Then what we'll get? That is a into a square lambda plus ax1 plus b into b lambda, that is b square lambda plus by1 plus c is equal to 0 plus c is equal to 0. Now from these two terms I am taking lambda common. Lambda is equal to a square plus b square, and the other terms I am shifting to the other side. So I'll get minus of the all terms. So I am taking minus of ax1 plus by1 plus c. Then lambda is equal to how much? Minus of ax1 plus by1 plus c by a square plus b square. A square plus b square. So here I am substituting that, so that I am getting the foot of h minus x1 by a is equal to k minus y1 by b is equal to how much? Minus of ax1 is equal to minus of ax1 plus by1 plus c by a square plus b square. A square plus b square. That is the foot of the perpendicular from the given point. This is how we will find the foot of the perpendicular from the given point. So just we will have, just see once again, they have given a line and they have given a point. From that point there is a foot of the perpendicular q h comma k on this line. We need to find the values of h comma k, and how we have to find that values? We'll get these values by h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by under root by a square plus b square. So first the equation, first what is it? This line PQ line is perpendicular to L. PQ line is perpendicular to the line L. What is line L? Ax plus by plus c. We know if the lines are perpendicular, then the equations are given by bx minus ay. So bx minus ay is equal to 0. As this point P lies on this line PQ, therefore I am substituting the point B into x1 minus a into y1 is equal to 0. And also the Q is also is on this line, therefore we are writing BH minus AY is equal to 0. Now we are equating these two. So BH minus AK is equal to BH minus AK is equal to B into x1 minus A. Minus b x1 is equal to ak minus ay1. Ak minus ay1. Take b common, h minus x1 is equal to, if I take a common, k minus y1. Then just by cross multiply, that is taking this a to the other side and b to the another side. So we'll get it as h minus x1 by a is equal to k minus y1 by b. Let it be. To find the value of h and k, we are equating it to some lambda. So we are equating it to lambda. H minus x1 by a is equal to lambda and k minus y1 by b is equal to lambda. H is equal to, so from this what can we get? We can get the value of h. H is equal to a lambda plus x1. K is equal to b lambda plus y1. We know that q also lies on this line. So we are substituting in place of x and y in this line h comma k. What are h comma k values? These are the values. So when we multiply inside, we are taking lambda common from these two terms. So we are getting lambda is equal to a square plus b square is equal to minus ax1 plus by1 plus c. Lambda is equal to what? Minus of ax1 plus by1 plus c by a square plus b square. So in this equation, we are substituting the lambda value, that is h minus x1 by a is equal to K minus y1 by b is equal to what is lambda we got? That is minus of ax1 plus by1 plus c by a square plus b square. That is how we will find. So next, so let us see a problem. So find the foot of the perpendicular from the point they have given minus 1 comma 3 on the straight line. The straight line they have given as pi x minus y minus 8 is equal to 0. And the point P of x1 comma y1 they have given as minus 1 comma 3. They have not mentioned h comma k. They have not mentioned h comma k. Q h comma k is not mentioned. So we need to find h comma k. How to find? We know the formula. We know the formula that h minus x1 by a is equal to k minus y1 by b is equal to minus a x1 plus b y1 plus c by a square plus b square. A square plus b square. So h minus x1 is equal to minus 1, that is minus 1. What is a? A is 5 is equal to k. We don't know k. Minus 3. What is b? B is minus 1. That is equal to minus of 5 into x, 5 into minus 1 plus minus 1 into 3 plus minus 18 by a square. What is a? 5 square plus minus 1 whole square. 5 square plus minus 1 whole square. That is equal to how much? That is equal to minus of minus plus, that is 5, k minus 3 by minus 1. So how much we'll get that? That is minus 5, minus 5, minus 5 minus 3, minus 8, minus 18. Minus 8 minus 18 is 26. So mod of that is 26 by 25 by 26 is, again we'll get 26. Here we'll get cancelled. So it will be 1. So it will be how much? 1. So h plus 1, h plus 1 by 5 is equal to 1 and k minus 3 by minus 1 is equal to 1. So this implies what? H plus 1 is equal to 5. H is equal to 5 minus 1. H is equal to 4. And what about k? K minus 3 by minus 1 is equal to 1. So k minus 3, minus 1 into 1 is minus 1. K is equal to minus 1 plus 3. So k is equal to 2. So h comma k is equal to how much? 4 comma 2. H comma k is equal to how much? 4 comma 2. This is how we will find, if they have given the equation and the point, then how to find the foot of the perpendicular. Foot of the perpendicular. This is how we will find the foot of the perpendicular. So next we have a theorem. We need to find, we have found the foot of the perpendicular in the just now. Now we need to find the image. We need to find the image. If Q h comma k is the image of the point P x1 y1 with respect to the straight line ax plus by plus c is equal to 0, then the equation is given by this one. That is, there is a line L and there is a point P. For this, there is an image. It will be image will be formed at an equal distance. Let it be some Q h comma k. Q h comma k. Then how to find the how to find that? How to find the image? How to find this image? So let us see. Q h comma k is the image is the image of point P x1 comma y1 with respect to the line, with respect to the line ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. As these two are at equal distance, we can consider this as a midpoint. So we are taking a point. Therefore, x 2 comma y1 plus k by 2 is a point, uh, is perpendicular, is the foot of the perpendicular, is foot of perpendicular from P on the line L, So this will become the midpoint. So if I take, this will become the foot of the perpendicular from P onto this line. We know that what is the equation of the foot of the perpendicular from that to this line is h minus x1 by a and y minus k minus y1 by b is equal to minus a x1 plus b y1 plus c by a square plus b square, But in place of x1, I have, but in place of h, what I have this value, but in place of h, what I have this, and in place of k, I have this value. So I'm substituting in this. What we'll get, that is x1 plus h by 2 minus x1 by a is equal to y1 plus k by 2 minus y1 by a is equal to minus ax1 plus by1 plus c by a square plus b square, So a square plus b square. So what we'll get, that is x1 plus h. If I take LCM, that is 2x1 by 2a is equal to y1 plus k minus 2y1 by a is equal to minus of ax1 plus by1 plus c by a square plus b square. So this implies what? x1 minus 2x1 is minus x1, h minus x1 by 2a, y minus k1 by 2a is equal to minus a, x1 plus by1 plus c by a square plus b square. So 2, if I multiply with 2, so what will get? H minus x1 by a is equal to y minus k, so this is k minus y1. K minus y1 by a by b, here b, by b is equal to how much? Minus 2 times of a x1 plus b y1 plus c by a square plus b square, So just see once again. So what we have done, we need to find the distance. So if we get the midpoint, if we get the point on this line, how the point on this line, if these 2 points are considered, then the point on this line is nothing but the midpoint, So we need to take the midpoint of these 2 points, that is x1 plus h by 2, y1 plus k by 2. So we know that foot of the perpendicular is given by h minus x1 by a, k minus y1 by b is equals to minus of a1 plus by1 plus c by a square plus b square. So what is h over here? In place of h, what I have? x1 plus h by 2. In place of k, what I have? y1 plus k by 2. So we are substituting in place of that, we are substituting that two lines. We are substituting that 2 points. So x1 plus h by 2 minus x1 by a, y1 plus k by 2 minus y1 by b is equals to minus a x1 plus b y1 plus c by a square plus b square. Now if we take LCM, x1 plus h minus 2 x1 by 2a is equals to y1 plus k minus 2 y1 by b is equals to minus of a x1 plus b y1 as it is we have written. So once we simplify this, we will get this as the equation, that is h minus x1 by a is equals to k minus y1 by b is equals to minus 2 times of a x1 plus b y1 plus c by a square plus b square. That is how we can find the image for the given point. That is how we can find the image for the given point. So we have a similar, we just will see a problem. What is the problem? Find the image of 1 comma minus 2. Find the image of what? 1 comma minus 2 with respect to your line. They have given a point x1 comma y1 is equal to how much? 1 comma minus 2, and they have also mentioned the line. The line is equal to how much? 2x minus 3y plus 5 is equal to 0, and they are asking us to find the image for this point. Image of point P x1 comma y1 is given by, we know the formula, that is h minus x1 by a is equal to k minus y1 by b is equal to minus 2 times of a x1 plus b y1 plus c by a square plus b square. To substitute the points, so we'll get the image h minus the image of the point. Okay, h minus what is x1 1 by what is a 2 is equal to k minus y1. K minus y1 is minus 2, b is minus 3 is equal to minus 2 into what is a? A is 2. What is x1? X1 is
Can you close
1.
it?
Yes sir, after this time I'll close it. What is b here? B is minus 3, y1 is minus 2 plus c is 5 by a square. A square is 2 square plus minus 3 square. A square is 2 square plus minus 3 square. So how much you get? H minus 1 by 2 is equal to k plus 2 by minus 3 is equal to minus 2 times of 2 plus or minus minus 3. Minus of minus will become plus 6 plus 5 by, how much we'll get? That is 2 square is 4. 4 plus 3 square is 9, 13. 2 square is 9, 13. So we'll get it as, that is h minus 1 by 2 is equal to k plus 2 by minus 3 is equal to minus 2 into 6 plus 11, 13 by 13. 13, 13 gets cancelled, we'll get minus 2. Therefore, equating h minus 1 by 2 is equal to minus 2 and k plus 2 by minus 3 is equal to how much we will get? That is a minus 2. So h minus 1 is equal to minus 4, h is equal to minus 4 plus 1, h is equal to minus 3, and k plus 2 is equal to minus 2 into minus 2 is 6. Minus of minus will become plus, which is a 6. So k is equal to 6 minus 2, k is equal to 4. Therefore, image is nothing but minus 3 comma 4. So this is how we find the image at the given point. If a line is specified and point is specified, then how to find the image? This is how we find the image. So we have some problems in the exercise to find the distance, that is the perpendicular distance in exercise 3D. Exercise 3D, problem number 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, and the second sixth problem, and the second sixth problem 7 and 8. You all have to do it as a homework. You all need to do it as a homework. Problem number 5, 6, 7, 8. And in the second week, you have it as a 6, 7, 8. So this, take it as a homework and you need to complete this homework. Okay, thank you. Thank you all. Here in the class. Thank you.